Magandang araw! Sama-sama tayong matuto sa Teacher Sal Learning Resource Channel.
Revised K-12 Curriculum, Math 3, Quarter 3, Week 3, Data and Probability. For Day 1, describe outcomes in real-life situations using the phrases likely, unlikely, most likely, and least likely. What is likely to happen if you study your lessons several days before your test? Why? It is likely that I will get a high score because I have been studying and preparing for the test for several days. What if you did not study your lessons before your test? What could possibly happen? It is unlikely that I will get a high score. Our lesson purpose is to use the phrases likely, unlikely, most likely, and least likely in describing outcomes in real-life situations. Let's be familiarized with these terms. Likely, unlikely, least likely, most likely, outcome, chance. Look at Table A. What is inside this container? Inside the container are bottle cups. How many bottle cups are there in all? There are 10 bottle cups. Write 10 beside the total number of cups written at the last row of the table. What can you say about the bottle cups in the container? There are 2 different colors of bottle cups in the container. There are many bottle cups in the container. What are the colors of the cups in the container? There are blue and green cups. Let's uncover the heading of the first column. How many bottle cups are blue? How many are green? There are 8 blue cups and 2 green cups. On the chart, let's uncover the heading of the second column. Write the number of cups for each color on the chart. What part of the total number of cups are blue? How about the green cups? The blue cups are 8 out of 10 cups or 8/10 of the total cups, while the red cups are 2 out of 10 cups or 2/10 of the total cups. On the chart, let's uncover the heading of the third column. In line with the blue color, write 8 out of 10 or 8/10. In line with the green color, write 2 out of 10 or 2/10. Suppose one of you will pick a cup from the container with your eyes closed. Which color of the bottle cup are you likely to pick? Why do you think so? It is likely to be a blue cup because there are more blue cups, 8/10, than green cups, 2/10. Observably, there are more blue cups on the chart than green cups. Since this is the case, the chance or likelihood of picking a blue cup from the container is greater than the chance of picking a green cup. We can say that the outcome, which is picking a blue cup from the container, is likely to happen. We use the phrase likely to happen for an outcome that has a greater chance of happening compared to other possible outcomes. Consequently, we say that the chance of picking a green cup is unlikely to happen since the green cups are only 2/10 of the total cups. We say likely to happen for an outcome that has a greater chance of happening compared to all other possible outcomes. We say unlikely to happen for an outcome that has a lesser chance of happening compared to all other possible outcomes. On the chart, let's uncover the heading of the fourth column. Under this column, in the second row, write likely in line with the blue color of cup and unlikely in line with the green color of cup. The completed chart is as follows. One at a time, 10 of you will pick a cup with your eyes closed. I will record the results using tally marks. Make sure to put the cup back into the container and mix the cups well before the next person picks. What are the different colors of cups? The colors are white, blue, and green. How many are colored white? There are 30 white cups. How about blue and green cups? There are 9 blue cups and 1 green cup. How many cups are there in all? There are 40 cups in all. What part of the total number of cups are white cups? The white cups are 30 out of 40 of the total cups. Write 30 40ths in row 2 of the third column. What part of the total number of cups are green cups? The green cup is 1 out of 40 or 1/40th of the total cups. Write 1/40th in row 4 of the third column. Identify what these fractions are called, then arrange them from least to greatest. The fractions are similar fractions because all their denominators are the same. Expected answer: 1/40th, 9/40ths, 30/40ths. Which of the three fractions has the greatest value? It is 30/40ths. How do you know? This fraction has the greatest numerator among the three fractions. Which outcome does it represent? It represents picking a white cup. Since picking a white cup has the greatest chance of happening compared to the other possible outcomes, it is most likely to happen. Write most likely in row 2 of the fourth column. We say most likely to happen for an outcome that has the greatest chance of happening compared to all other possible outcomes. Which of the fractions is the least? It is 1/40th. How do you know? This fraction has the least numerator among the three fractions. Which outcome does it represent? It represents picking a green cap. Since picking a green cap has the least chance of happening compared to the other possible outcomes, it is least likely to happen or very unlikely to happen. The first one is more often used than the second one. Write least likely in row 4 of the fourth column. We say least likely to happen for an outcome that has the least chance of happening compared to all other possible outcomes. What about picking a blue cap? What fraction corresponds to picking a blue cap? It is 9/40ths. Since the chance of picking a blue cap is also small, though not as small as picking a green cap, we can say that picking a blue cap is unlikely to happen. Write unlikely in row 3 of the fourth column. When do we say that an outcome is likely to happen? What about unlikely to happen? What about most likely to happen? What about least likely to happen? The container below has the following balls: 25 white balls, 3 dotted balls, 10 gray balls, 1 striped ball. Which colored ball is most likely to be picked from the container? Which two colored balls are unlikely to be picked from the container? Asmar has 10 identical balls to be added to the container. Adding all his balls to the container will make the dotted ball the least likely to be picked. What kind of balls does Akmar have? Explain your answer. Here are the expected answers. For day 2, describe outcomes in real-life situations using the phrases equally, likely, certain to happen, and impossible to happen. Our lesson purpose is to use the phrases equally, likely, certain to happen, and impossible to happen in describing outcomes in real-life situations. Let's be familiarized with these terms: equally like, certain, impossible, outcome, chance. Look at the red spinner. It has an arrow pointer that you can spin. Share your observations about it. The entire region of the spinner is color red. The spinner is round. What would surely happen if I spun the arrow pointer? The arrow pointer will stop at a red region. Why? It is because there are no other colors on the spinner except red. Observably, the entire region of the spinner is colored red. Since this is the case, the chance of the arrow pointer stopping at a red region is certain to happen. We can say that the outcome, which is the arrow pointer stopping at a red region, is certain to happen. We say certain to happen for an outcome that is sure or definite to happen. We say certain to happen for an outcome that is sure or definite to happen. Looking at the same spinner, is it possible for the arrow pointer to stop at a blue region when spun? No, it is not possible. Why? It is because there is no blue region on the spinner. The entire region is colored red. Since the entire region is colored red, the chance of the arrow pointer stopping at a blue region or any color not red will never happen. In this case, we can say that the outcome, which is the arrow pointer stopping at a blue region, is impossible to happen. We say impossible to happen for an outcome that will never happen. We say impossible to happen for an outcome that will never happen. Share your observations about the spinner. The spinner is divided into two equal parts. One equal part is colored green, while the other is colored yellow. The spinner has an arrow pointer that can be spun. The spinner is round. What is impossible to happen if I spun the arrow pointer? It is impossible for the arrow pointer to stop at a red region. Why? It is because there are no parts of the spinner that are colored red. What is certain to happen if I spun the arrow pointer? Why? It is certain that the arrow pointer will stop at a colored part of the spinner because the spinner has colored sections. The arrow will stop at one of them. It is certain that the arrow pointer will not stop at a red region because there is no red region on the spinner. The arrow cannot stop at red. You mentioned earlier as one of your observations that the spinner is divided into two equal parts. One part is colored green and the other is colored yellow. Suppose you will spin the arrow pointer a couple of times. What could happen to the arrow pointer? Why? The arrow pointer would stop an equal number of times at the green and yellow regions. This is because the green and yellow regions on the spinner are of the same size. Since the spinner is divided into two equal parts, the arrow pointer is equally likely to stop at the green and yellow regions. We say equally likely to happen for each outcome that has an equal chance of occurring. We say equally likely to happen for each outcome that has an equal chance of happening. Come to the front one at a time and spin the arrow pointer. We will tally how many times the arrow stops on each color. After several spins, we will compare the results to see if the arrow stops on yellow about as many times as it stops on green. There are two containers, A and B. Container A has white balls. Container B has white, black, and two colored balls. Let us count the number of balls in each container. Count the number of balls. Container A, white balls 12. Container B, white balls 4. Black balls 4. Two colored balls 4. In which container is picking a white ball certain to happen? Why? It is in container A that picking a white ball is certain to happen because all the balls in that container are white. In which container is picking a white ball certain to happen? Why? Why not in container B where there are also white balls? There may be white balls in container B, but there are also black and two colored balls. There are three possible colors of balls that could be picked. In which container is impossible to pick a white ball? Why? None. In both containers, it is possible to pick a white ball. What is certain to happen when you pick a ball from container B? Why? It is certain that we will pick a colored ball because all the balls in the container are colored. What is impossible to happen when you pick a ball from any of the containers? Why? It is impossible to pick an orange ball because there are no orange balls in either container. In container B, there are equal number of white, black, and two colored balls, 4 of each. What can you say about how likely it is to pick a two-colored ball, a white ball or a black ball in container B? Why? It is equally likely to pick a two-colored ball, a white ball, or a black ball because there are an equal number of each type in container B. When do we say that an outcome is certain to happen? What about impossible to happen? What about equally likely to happen? Below are number cards. What numbers should be written on the cards that will satisfy all the following conditions? It is certain that a single-digit number will be picked from these cards. It is impossible to pick a 0 from these cards. The numbers 1 to 9 have equal chances of being picked from these cards. Write the number on each card. For the expected answer, the number cards are from 1 to 9. For day 3, perform simple experiments and record outcomes in a table, and describe outcomes of simple experiments using the phrases likely, unlikely, and equally likely. Our lesson purpose is to perform simple experiment, record outcome in a table, and describe the outcome of a simple experiment using the phrases likely, unlikely, and equally likely. You will work in groups for an experiment. Form 4 groups and each group will receive the materials prepared for this activity. Look at the spinner. Look at the table. Make sure that you have the following materials before you perform the experiment. Open the manila paper. Ask each member of the group to write their names on the first column of the table. Let each group member take turns spinning the arrow pointer once. After each spin, record the color where the arrow pointer stops in the table. Looking at the spinner, what is likely to happen when you spin the arrow pointer? Why? It is likely to stop at the red part of the spinner because red part is the largest. The outcome of the arrow pointer stopping at the red part has a greater chance of happening compared to all other outcomes. What is unlikely to happen when you spin the arrow pointer? Why? It is unlikely to stop at the blue part of the spinner because only a small part of the spinner is colored blue. The outcome of the arrow pointer stopping at the blue part has a lesser chance of happening compared to all the other possible outcomes. What can you say about the number of times the arrow pointer would stop at the green part compared to the number of times it would stop at the yellow part of the spinner? Why? It is equally likely that the arrow pointer would stop at the green part and yellow part of the spinner because the green and yellow sections are the same size. Based on what you know about likely, unlikely, and equally likely outcomes, ask each group to make predictions about how many times the arrow pointer will stop at a specific color before conducting the experiment. Write your predictions on the strips of paper, then explain why you made those predictions. We will check if your predictions make sense. Once you finish your predictions, pause your strips of paper on the board. Make sure there is enough space between each group because you will pause your experiment results beside your predictions later. Some possible predictions. For group 1, the arrow pointer will stop at the red region 7 times, green region 1 time, yellow region 1 time, blue region 1 time. Group 2, the arrow pointer will stop at the red region 5 times, green region 2 times, yellow region 2 times, blue region 1 time. Group 3, the arrow pointer will stop at the red region 6 times, green region 2 times, yellow region 2 times, blue region 0. Group 4, the arrow pointer will stop at the red region 3 times, green region 3 times, yellow region 3 times, blue region 1 time. Let us see which of your predictions match your actual results. You can now start your experiment. When you finish, pause your results on the board next to your prediction strips. Did each group get the same result? No, we did not. In which group did the arrow pointer stop at the red region the most number of times? In which group did the arrow pointer stop at the blue region the least number of times? In which group did the arrow pointer stop at the green and yellow regions the same number of times? The desired results may not be achieved, as the number of trials conducted was only 10. It may be necessary to conduct more trials to get a more accurate result. The arrow is likely to stop at the red region. The arrow is unlikely to stop at the blue region. The arrow is equally likely to stop at the yellow and green regions. Here is a table, the number of times the arrow pointer stops at each color. Each group will write the results of your experiment on the chart, one group at a time. Make sure the data on the chart shows the actual results of your activity. Let us now get the total for each color. Write the total in the last row for each color. In which part of the spinner did the arrow pointer stop the most number of times? It is in the red part of the spinner. How many times did the arrow pointer stop at the red part of the spinner? It stopped at the red part of the spinner 23 times out of 40. What is the possible reason the arrow pointer stopped the most number of times in the red part of the spinner? It is because the largest part of the spinner is colored red. Since the red part is the largest among all the parts of the spinner, can we say that the arrow pointer is likely to stop at the red part? Why? Yes, we can, because the larger the part, the greater the chance that the arrow pointer will stop at that part. In which part of the spinner did the arrow pointer stop the least number of times? It is in the blue part of the spinner. How many times did the arrow pointer stop at the blue part of the spinner? It stopped at the blue part of the spinner 2 times. What is the possible reason the arrow pointer stopped the least number of times in the blue part of the spinner? It is because the smallest part of the spinner is colored blue. Since the blue part is the smallest among all the parts of the spinner, can we then say that the arrow pointer is unlikely to stop at the blue part? Why? Yes, we can, because the smaller the part, the lesser the chance that the arrow pointer will stop at that part. What can you say about the number of times the arrow pointer stopped at the green part of the spinner compared to the number of times it stopped at the yellow part of the spinner? The number of times the arrow pointer stopped at the yellow part is almost the same as the number of times it stopped at the green part of the spinner. How many times did the arrow pointer stop at the green part? How about at the yellow part? It stopped at the green part 8 times and at the yellow part 7 times. What is the possible reason that these numbers are almost the same, or that the difference between these numbers is just 1? It is because the yellow and green parts are equal in size. Since the green part and yellow part are equal in size, can we say that it is equally likely that the arrow pointer will stop at the green part and yellow part of the spinner? Why? Yes, we can. Since the two parts are equal in size, the arrow pointer has an equal chance of stopping at either part. How do you describe outcomes based on the result of an experiment? We describe outcomes based on how likely, unlikely, or equally likely they are to happen. An outcome is likely to happen if it has a greater chance of happening compared to all other possible outcomes. Unlikely to happen if it has a lesser chance of happening compared to all other possible outcomes. Equally likely to happen if each possible outcome has an equal chance of occurring. The result of an experiment using a letter, board, and a chip was recorded in the table shown. Based on the data in the table, answer the following. Suppose the chip is shown again on the letterboard. In which letter would it likely land? Why? In which letter would it unlikely land? Why? In which letter between C or D would it likely land? Why? Which of the following board was used in the experiment? Board 1 or board 2? How did you know? Here are the expected answers. For number 2, For day 4, describe outcomes of simple experiments using the phrases equally, likely, most likely, least likely, certain, and impossible to happen. Here is our lesson purpose. What is the chart all about? It is about the result of picking a card with a shape. What shapes could be seen in the cards? The shapes were triangle, square, star, and heart. Which cards were picked the most number of times? The cards with a heart and a triangle were picked the most number of times. How many times were these cards picked? The cards were picked for 21 times. Which cards were picked the least number of times? It is the card with a square. How many times was this card picked? It was picked only one time. How do you compare the number of times the card with a triangle was picked with the number of times the card with a heart was picked? The number of times the card with a triangle was picked is equal to the number of times the card with a heart was picked. Based on the data in the table, what outcome is most likely to happen when you pick a card with a shape? Why? It is most likely that I would pick either the card with a heart or the card with a triangle because both shapes have the highest results in the table, which is 2. What outcomes are equally likely to happen? Why? Picking a card with a heart and picking a card with a triangle are equally likely because the results in the table show that these shapes have the same result, which is 21. What outcome is least likely to happen when you pick a card with a shape? Why? It is least likely that I would pick the card with a square because this shape has the lowest result in the table, which is 1. What outcome do you think is certain to happen when you pick a card with shape? How about impossible to happen? Why? Some possible answers: it is certain that I will pick a card with a shape because all the cards have shapes on them. It is impossible that I will pick a card with a number or a letter because all the cards have shapes and there are no numbers or letters on them. Work with a partner. Based on the data in the table, each partner should describe and explain what outcomes are most likely, least likely, equally likely, certain, and impossible to happen. Most likely outcome: the ring landing on the mango picture is most likely to happen because mango has the highest number in the table. Least likely outcome: equally likely outcomes. Certain outcome. Impossible outcome. It is impossible that the ring will land on the apple picture because there is no apple picture in the table. How do you describe outcomes based on the result of an experiment? An outcome is most likely to happen if it has the greatest chance of happening compared to all other possible outcomes. Least likely to happen. Equally likely to happen. Certain to happen. Impossible to happen. The result of an experiment on spotting an animal is presented in the given table. Based on the data in the table, answer the following questions. What outcome is most likely to happen when you spot an animal? Explain. Why? What outcome is this likely to happen when you spot an animal? Explain why. What outcomes are equally likely to happen when you spot an animal? Explain why. Write an outcome that is certain to happen, impossible to happen. Here are the expected answers.